photovoltaics. So in solar photovoltaics, there are different characteristics, and you have to identify and analyze those characteristics by by some tasks. Okay. So what types of characteristics we will later discuss. So this simulation will be in the Matlab, and the file is already provided, I guess. So this is the task one. It is very important to uh, understand the task very carefully. So task one is basically contains 80%, which means the largest part of your this lab, which is 80%. Okay. So basically here we will do some fundamental, very basic characteristics by doing some tasks. So first we will use the file, which is lab1 task ps. Then we have to draw and analyze IV, which is current and voltage, and PV, which is power and voltage curves for the different solar irradiance. So 200 to 1000. Okay. So we have different irradiance values, and you have to analyze for IV and PV for different one. Okay, that's good. So this is the first and basic part of your uh, lab 1. Okay, then try to understand the task 2. So basically this one is not the task, this is a statement which is just similar to the task 1. And the point 2 is basically the similar to this one. They said 200 to 1000, and here they said only 1000. So you don't need to do this one particularly. You can do this one as a similar to the task 2. So basically the task 2 is this number 3, where you need to do some analysis on the short circuit current, open circuit voltage, and you need to analyze the power. What types of power once you have the short circuit and open circuit voltage you have. Okay, so uh, now we'll go to the Matlab file. Okay, so let's try to analyze. Okay, this is very slow, so we need to wait every time. Okay. Okay, so I think you have all the files for the lab 1. So basically, first try to understand what is the diagram is. Okay, sorry for the slow PC because it's trying to uh, all time. If you give any instructions, it takes some time. Okay, so this is the solar photovoltaic system which we are talking for, the PV. Okay, photovoltaic. So this is the input part. You can see the input part where you have connected the irradiance. Okay, I will discuss what is the irradiance is. Then we have two terminals where we have connected a loads by grounding for for complete the circuit. And here we have three terminals for voltage, current and power. Okay, we have another module which I included here, which is the XY graph. Okay, so basically once you go to the library and you put the XY, you can just see the XY block here and just put here. We just put it to see the curve. Okay, so no issues. Sorry. So first we have to do the irradiance part. So basically what is irradiance? This is this input part. So irradiance is basically the light, sunlight. Okay, in which units your sunlight is falling into your solar surface is the irradiance. So that is why uh, the the unit is watt meter per square. Okay, so this is the irradiance we have. So once you got the input irradiance, you will get some output. So in that case, your input is, for every times your solar input is the solar sunlight, okay, which is the irradiance. So you have some different irradiance. It means solar irradiance is different. Okay, so now we will we'll try to do the tasks here. Okay, so once you open the file, you will also see that a signal, what they call signal builder file is will also open. Okay, so you can see we have different irradiance because in our task they said that you have to simulate for different irradiance: 200, 400, 600, 800 and 1000. So how you can set that? It is already been set it here. Okay, so if you want to set it from the beginning, you need to click the button signal. Still it's very slow. Okay, so replace with, once you click the signal, you can see the replace with, and you can see the custom. Click the custom. Oh, it's taking time. Okay, so you can put here the time values. Okay, so here is the time part and this is the irradiance. So the time is starting from the 0. So just put here a third bracket, time for 0, 1, 2, 3 and 4. And in the y value, put the irradiance values like 200, 400, 600, 800 and 1000. Okay, so we have uh, different, we have put it the different irradiance value and then okay, and you will see the similar curve. Okay, like for 0 it is 200, for 1 it is 400, for 2 it is 600, for 3 it is for 800 and last of all it is 800. Okay, sorry, 1000. So this is the signal builder part. So first you have to complete it and then this is the analyzing part. Okay, so the important part is that you have to analyze IV and PV curve. Okay, you can see IV, PV. So here V is y-axis in both cases. Okay, so if we choose this one, uh, is the this one I am connecting with the voltage part. Okay, and this one I am also connecting with the voltage, and this one I am connecting with the current for uh, IV, and this one I am connecting for the PV power. So how you can get those you know the blocks? Just go to the library and put this one, the Simulink library, and just put here the XY and just drag it to your uh, interface, and you can just put the XY block here. Okay, another thing you have to do, that you have to set some intermediate values here, otherwise you can't see any curves here. So just see the intermediate values. Okay, so basically uh, in your in your blocks, maybe it will be -1 and this will be 1, -1 to 1 or -1 something, but try to change it to the x means 0 to 5, y 0 to 5. Okay, so that we can see a elaborate curve. Then okay it, do it also similar thing for it. Okay, so like this one, -1 to 1, so I am just changing it to 0 to 5, or you can put 0 to 4 also, 0 to 5. Okay, then apply and then okay.
Sir, I have a question.
Yes, sure.
Can Matlab 2016 version build this effect?
Ah, no, it may, this file can only be run in 2018.
Oh, because my laptop doesn't support the latest one.
Oh,
Slow.
okay.
Slow. Okay, okay.
Yeah, 2018 is will be the good one. Okay, so no issues. You can do it later, no issues. Okay. So I put some values here. Now I will do some simulation to see how the curves looks like. So the issue is that it will take some time because my PC is also slow. So I just click the simulation button. Now see. Oh, it will take some time. Okay, does anyone run the simulation?
Not yet, sir.
Not yet. If anyone run the simulation, it could be better because here my it will take some time. It's now only 2%. So if anyone uh, run the simulation, then we can see the plots. Try to simulate it because we have a rubric part where you need to put some tasks. You need to do some tasks. So try to simulate it. If anyone do the simulation complete, then kindly let me know. Oh, it's not simulated. Zero to one. I have put 4 to 5. Still running. Oh, it was some time. Anyone complete the simulation?
Mine say it's not compatible, sir. It needs 2018B version.
Okay, okay. Have you completed?
Yes, yes.
Okay, if you complete it, then can you see the curves? Have you seen the curves?
Yes, I can see a graph. There's two graphs.
Okay, then is it Faris Azmi?
Yes, that is me.
Okay, can you share the screen to us so that because it's taking some time so that we can
All right.
see your curves here. Okay, so I'm stopping from my side. Kindly share so that we can see how the curves look like. Otherwise, we need to change. Okay. So, okay. So share your screen. Yeah, just share your screen. Yeah, we can see your screen. So just open the Matlab.
This one. Oops. Can you see my MATLAB?
Uh, Not yet. Maybe it's coming.
Oh, yeah. Wait a second.
You can just minimize the, what it called, Teams.
Okay, wait a second.
Sure. Yeah, we can see. Great. Okay. So, uh, yeah, the two plots. You have two plots. The upper one is the, if I'm not wrong, the upper one is the IV, and
the upper one, yes.
the lower one is the PV.
Yes.
Okay. So the discussion is the important thing, that what you are seeing. So basically, once you are you are increasing the current values, the voltage is also increasing here, and the lower one is basically discussing that once you are increasing the uh, power, it's also increasing the voltage as well. So uh, in your lab reports, just you have to put the curves here and just need to discuss that what you are seeing here. Okay, so basically the curves could be changed, because I just put some intermediate value to 0 to 5 x-axis, 0 to 5 in y-axis, but it could be changed once you put other values, but the pattern should be the same. Okay, so this is the first task. Can you open the manual? Yeah, that's great. So basically, this is the first task what we have already did. First, we have uh, set the signals for different signals: 200, 400, 600, 800, and 1000. And then we have analyzed IV and PV curve. So this one is the task one, which we already did. Okay, so 80% is complete from this lab. Now the rest of 20% is basically that you have to do some short circuit analysis, open circuit voltage, and see the power, because the number 2 point is basically is just similar to the task 1, where you just only need to analyze the 1000. Once we get the 1000 values of irradiance, what will happen. Okay, so okay, so can you open the Matlab? Yeah. just close down the curves. Okay, so first we will do short circuit analysis. Okay, so you can see that there is a load resistance, the red one. Yeah,
Yes.
just click it. Yeah, double click. Yeah. Okay, you can see the value is 10. Okay, initially the value is 10. Okay, once you are doing the short circuit analysis, our concentration is that the highest current or the maximum current can flow. Okay, so that is why we will put here like a smaller value of resistance, which is like 0.0001. Okay, 0.0001.
0, 1, like this.
Okay, yeah, write this. Okay, then okay, this is for the short circuit. Okay, then run. Okay, okay, we are not interested in the the curves. We are interested to see the display, the green one.
This one.
Yeah, can you zoom it? Yeah, just it's yes, right. So the short circuit current, you can see the values of the short. Once you are putting the uh, very negligible of resistance, you can see that your voltage, current, and the power. Okay, so in your lab reports here you have just mentioned, once you put the short circuit analysis, what is your voltage, what is your current, and what is the power you have got. Okay, so this is basically the short circuit current. Okay, analysis. Okay, now we will we'll do the open circuits. Okay, so basically for the open circuit, you can just click to the the resistance, the red one.
Wait, this one.
Resistance, yeah, the load resistance, yes, just need to change. Okay, so now open circuit, here our target is to minimize the current. So if you want to minimize the current, you have to maximize the resistance value.
Resistance.
So yeah, so try to put a large number like 1000. Is it okay, then run and see the values. Okay, just cross the xy curve. Okay, so you can see the voltage, open circuit voltage is very much high, the current is very low, and the power is also okay. So you can see that this is the open circuit voltage you have. Okay, so generally uh, in your lab reports you have to do short circuit terms and just need to analyze the what you are seeing here, like what is the voltage, what is the current, what is the power you have. Okay, and also similar to the open circuit voltage. Okay, so now you can go to the lab manual. Okay, so basically here they are talking about the short circuit current, open circuit voltage, and basically in the maximum power, once you have the the uh, the power equation is basically P equal to VI. So if you say that V equal to IR, that it will be I square R for P. Okay, so once you have the largest value of resistance, you will get the maximum power here from the equation. Okay, so basically you just need to put the open circuit voltage analysis power similar to the short circuit analysis power, uh, that what power you are seeing for these two analysis. Okay, so this is about the task 2, and the task 1 is already we have did. So basically this is a very fundamental where we basically just look about the IV PV curve and just some short analysis on the short circuit current, open circuit voltages. all those things. So basically this is a very fundamental solar PV, very small solar PV. It's not exactly look like the real one, but it is a very small, maybe the rooftop solar PV. So that's why once you have got some new solar PV, first you have to do some those characteristics to show that yes, it is going the right way. Otherwise you can't use this solar PV. Okay, so this is the task all about the lab ones we have. So basically we have also a rubric part, so we have to do the tasks individually. So do you have any questions before going to the rubric part?
So how do we change the value of irradiance in our MATLAB?
Okay, then just open to the signal builder. Do you have the file?
This one?
Yeah, this one. Oh yeah. Okay, just go to the signal,
Signal?
replace with
Custom?
custom. Yeah. Then just put the values like you have 0 to 5 here. So like first give a third bracket. Yeah.
Hard
Then
bracket?
0. Yeah.
0,
Third bracket. 1,
1,
2, 3,
3,
4. Then you will get 5 values here. And then put here 200, 400.
800 and 1000.
Yeah. Okay.
Okay.
So you see the
Yeah.
values. Okay, so like for 0 it's 200, for 1 it is 400. Just see the points. Okay, so the
Okay.
irradiance value is just ready for you. Okay, so then just you can run and it will run different. And if you want to uh, only one value for a whole time, you can just drag the signal. Try to drag it. Yeah, yeah. Just like if you want to increase in 1000, just give it to 1000. Yes.
This. Oh, okay. I see.
Okay, go to
Alright.
1000. Okay, and also increase the initial 0 part.
This one?
Yeah, and the last part. Yeah, this one. So what is
Uh,
actually indicating it? That 0 to 5 you have the same irradiance, 1000.
so this is how we change it. If we want
Yes,
200, we
yes,
change 200 like this.
yes, you can change it.
Okay. Alright. Thank you, sir.
Okay, okay. So okay, do you have any guys have any other questions? Then we can go to the rubric part where we can demonstrate by sharing your screen. Okay, so uh, I'll just go to the rubric part. Just and kindly let me know about the attendance because before ending session, I need to take the attendance. Okay, so first I'll go to Rais Hamizan bin Muhammad Tarmizi.
Yes, sir. I'm here.
Okay, okay. So, okay, Mr. Faris Azmi, thanks for the assistance. You can just now stop the sharing so that we
Uh,
can see the other screen. Okay, so
Alright,
just,
sir.
just stop this. Okay, so Mr. Tarmizi, okay, kindly share your screen and just demonstrate us that how you can set the signal builder value of the irradiance.
Sir, I'm so sorry, sir. I still can't run my program on my Matlab.
Okay, so what's the issue?
What, sir?
Is that not running?
No, because my Matlab is the old one, so I'm trying to download the new one.
Okay. No issues, no issues. You can download later. Okay, then just for the rubric part, I am just asking you some questions. Okay,
Okay.
some basic questions so that I can just evaluate you. Okay, so first is that just related to the irradiance part, that what is basically
Okay.
the irradiance is.
Um, what are the irradiances?
Right, the irradiance. Why we need the irradiance?
Mm, what is that?
Do you know the PV,
No, sir.
the photovoltaic solar cell? Have you seen the solar cell?
Uh, is it a flux power?
Uh, Basically, we don't need to Google, because I know that. I
Yes,
know.
I'm
Okay,
I'm
we
good with
we
it.
just we just want to discuss that. Yes, it's because we just discuss the fundamental of the PV. So just we want to share that yes, you have some basics or not. Otherwise, we can share to each other. Okay, so basically, the solar. If you see the solar cell, it is basically run by the sunlight. Okay, so once sunlight is fallen to the solar surface, it generates some, you know, some yeah, there's some movement of the electron and provides some currents. Okay, so basically the irradiance is that the sunlight which is fallen to the surface of the solar cell. So it is the irradiance. So once we have got higher irradiance, it is basically give you the uh, good outputs. Okay, so irradiance is basically how it's acting here, input or output in the solar cell. Mr. Tanmiji,
Yes, sir.
yeah,
Pardon?
irradiance is acting like what? Input or output?
Oh, as an input.
Input, and what we are expecting from the what would be the output?
The output will be the power.
Okay, the voltage, current, the power. Okay, okay, thank you. Okay, I'm just for your, yeah, I'm giving
Right.
you a good marks. I'm giving you 8.
Thank you, sir.
Okay, try to manage the MATLABs as early as possible, otherwise you can't do it. So try to, because you need to submit lab report, you know individually. Okay, then Muhammad Salman Farhan bin Muhammad Sufyan.
Yes, sir.
Okay, thank you. So can you kindly show us the, you know the PV IV curve?
Um, well, you mean the result of the
Yeah, that just we have IV PV. I'm just telling you to show the IV curve, just one curve.
IV curve? So,
In
according to
fact,
what that we just did now, when the current
yeah,
increase, the voltage will also increase.
yes, right. Just try to share your screen and just demonstrate us that yes,
Um,
yes.
I am the one that told you that I used the 2016 versions just now. I am Salman. So I cannot use it. It's incompatible. It said I have to download the 2018B version of Matlab.
Okay,
Sorry, sir. It's my bad. I think it will work, but it's not.
okay, okay. Then just okay. It should not be like that. Okay, because
Yeah, 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 yeah.
because you need to submit the lab reports and you need to follow the labs.
I will
Otherwise,
I will download the 2018 version lah.
yeah, it will be good. Okay, then ask me some questions. Okay, so basically, I'll ask you regarding to the like open circuits. So can you kindly tell me about the uh, open circuit? Here, what, how we can set the resistance value for the open circuit voltage?
For voltage,
Open
uh,
circuit.
just now we just set it to 0.00001, right?
Are you sure? Is it's for the open circuit?
Yeah, the part of open circuit, you change the what? The resistance.
Okay, but it's not the open circuit. It's for the
Or
short circuit.
1000.
Yes, right. 1000. But why
1000, right?
1000? Kindly explain me that. Then why 1000?
Mm,
What's the reason behind this? Once you get the higher resistance, what
yeah.
should be the lower one? Which should be the lower one?
The current will be lower. So
Right.
it
The current
current.
will be the lower. You're right. So it will like act as a open circuits. Okay, so
Yes.
basically this is the principle of the open circuit. So next time try to, you know, uh, what call this, try to install the Matlab,
Yes,
and
sir.
as well you need also the power software for the maybe from the experiment 2. So try to use the softwares, otherwise it will be very difficult to follow. Okay.
I'm sorry, sir. Okay.
Okay, it's okay. So I am giving you good numbers. I am giving 8 to you as well. Okay. So Muhammad Faris bin Azmi.
Yes, sir.
Okay. So you already help us, and just I am just asking you for one more demonstration, which is like just show us the IV curve.
The IV curve.
IV
Right.
curve. Yeah, just show us the IV curve, that how it looks like, and just share your screen. Okay.
So for the IV curve, oh wait,
Yeah, it should be like 10.
wait,
Which one is the IV?
wait second. IV is the top one.
The top one. Okay. So, what is indicating here?
It is indicating that when we increase our voltage, the current also increase.
Okay. So, in y-axis we have what?
In y-axis we have um, in y-axis we have current.
It's IV.
Oh, sorry, it's V.
So, y-axis it will be V.
V, yes,
Okay. And I-axis?
will be I. It will be
I.
x-axis.
I. Okay. So, once you are trying to increase the value of current, it is increasing the uh, value of voltage as well.
Yes.
Okay. Okay. Okay, and can you show me the, can you explain the lower one also, the PV one, because it
This
is,
one,
yeah, what is happening here?
what is happening? So if we increase, it's not linearly increase. So as we increase voltage,
Kindly tell me that in y-axis what we have?
in y-axis we have voltage,
Voltage, okay, and in x-axis we
we
have
have power.
power, okay. Then, yeah, sure. Then what is happening here?
The higher the voltage, power also
Okay,
increase. but it's not increasing. It's not increasing linearly.
Linearly. It is like exponentially.
Yeah, it's not. Yeah,
Okay,
exponentially.
okay, okay. Okay, thank you, Mr. Faris. Thank you for your explanation. I am giving you full marks. 10.
Thank you, sir.
Okay, thank you. Then Tajul Abdul Aziz bin Tajul Urus.
Yes, sir.
Okay, thank you. So can you just show me, can you show us the, if you want to analyze the short circuit current, then what you have to do? Kindly share your screen and demonstrate us the short circuit current. Yeah, we can see you.
Okay. Is it showing the Matlab?
Uh, Not yet.
Not yet.
Maybe you need to minimize. Yeah, now we can see
So is it the short circuit, right?
short circuit.
This one, sir.
Yeah. So how you can change the resistance value
Uh, for short circuit,
for short
it's
circuit?
the smallest resistance.
Right. Okay. So have you set the value?
Yes, yes.
How much you said? I couldn't.
0.0001 ohms.
Okay. So what's the reason behind this?
So when the resistance is low,
Mm-hmm.
there will be more current flowing. So it will
Okay.
be short circuit.
Okay. Okay. That's great. Okay. So have you already simulated?
Yes, yes.
Okay. So the values are showing here.
Ah,
Okay, so we are interested to see the values. So the values are showing that yes, you have a very low current, low voltage in the short circuits. Okay, and the current is good, and the power we have. Okay, so thank you to show me the show us the short circuit current. Okay, so thank you.
thank you, sir.
Thank you. So I'm giving you the full marks. 10. Okay, the last one. Tuan Ahmed Adam B. Tuan Zamri.
Can you hear me?
Yeah, I can hear you clearly. Okay, you can stop the your screen. Okay, yeah. So Mr. Zamri, you can share your screen and show us the open circuit voltage.
Okay, sir. Can you see the Matlab?
Yes.
For open circuit, we change the resistance to 1000
Why?
uh, to minimize the current.
Okay, to minimize the current, then it will look like a open circuits. Okay, basically in open
Yes.
circuits, the resistance is infinity. But if you put here infinity, it will not work because it is a current oriented solar cell. So you can't put infinity. That's why we are trying to put a
Put
large
the
number.
highest current.
You're
High
right. No,
resistance.
the lowest current.
Yeah,
What's the lowest?
higher resistance.
Okay, putting the higher resistance, right? So now simulate it.
Already, sir.
Already. Okay, then you can see the voltage is okay 199, which is the highest voltage here. If you put more larger value like 10,000, then it will show you
Uh,
more more
More voltage.
more voltage here, maybe. Okay, so okay, the current is also okay. So the main issue is that you have to analyze once you are how and why. How you putting the load resistance 1000, you have to explain that yes, this is the reason behind this, that I am putting 1000 here, and after simulating it, I am I can see the values, this, and why it's showing like this. This is the main issue. Okay, and what is the power for the open circuit and what is the power for the short circuit is. Okay, and you need to also analyze that where we are getting the higher power. Is it open circuit or the short circuit? So try to the message is for the everyone. Try to analyze deeply and try to always make a comparison between your lab reports so that you can getting the higher marks, so that it will make you more efficient. Okay, so try to analyze it, and your other labs also very much similar, where you need to some analyze and need to discuss your discussions that what you are seeing here. Okay, so thank you, Mr. Zamri. So I'm giving you the full marks 10. Thank you. Okay,
Thank you, sir.
so okay, so we are at just at end of the session. Before that, I'm trying. Okay, you can just stop your screen.
So can I ask something?
Sure, sure.
For the lab report, we have to do only result and discussion, right?
Results and discussion. I think in the lab manual there is a uh, organization part of your lab report. That's how you need to
Oh,
organize it.
alright.
Okay, so basically the issue is that you need to analyze the results very specifically, because the simulations are very much easier, or the very much fundamentals, but the analysis is the main important thing, that how your analysis is going on. Try to sometimes you need to put your comparisons, that yes, in the open circuit this voltage is like that, this is like that, so in this we are getting higher voltage, in short circuit we are getting lower voltage. So try to make some comparison and analysis, so that it will make the instructor that yes, you have the proper knowledge. Okay, because the results are very much easier, but the issue is that the analysis or the understanding you have is the very important issues. Okay, so I just downloaded that, and then so okay, if you have any questions you can ask me regarding the lab reports on anything.
Sir, for the lab report, must it be handwritten?
uh, I guess so, because maybe the Nuraliza,
Yeah.
she made an email uh, where she mentioned that maybe you need to write the lab report in handwritten, and then just scan it and then just email. Just you can put one thing, that once you are trying to mm, you know the curves, the diagrams or anything, you can just take a screenshot and just paste it in your uh, templates, and then you can just write down here. Okay.
That's
Okay. So any other questions?
Sir,
Yes.
when do we submit the report?
Generally, like by next week, generally. But I really don't know about the procedure of uh, this one, because generally it is always submit early so that you know you can be prepared for your other subjects. So I guess it should be 1 week maybe, but uh, the lab report will the lab report is basically controlling by Nuraliza, because every lab report will be in her email, and then she will uh, send us to the GS, which I know that, because so I think it's always better to submit maybe by next week, or you can just contact with the Nuraliza that okay, when we can submit the lab 1 report. Okay, so just mm, try to prepare it as early as possible. Okay, so that you can ready to it. Otherwise, you will just forget it. What discuss we have made. Okay, so just try to prepare as early as possible. Okay, so any other questions?
No, sir.
Okay, so if we don't have any questions, then we can end the session, and thank you all for joining the session, and be safe, and try to you know try to make yourself always prepared for anything, so that you can uh, do your work properly. Like here, two people have not uh, installed the Matlab, so uh, this should not be like that. You have to prepare early so that you can uh, execute all those things. It's a very important thing for everything, because for the next labs, maybe for the lab tools, you need to require Powerwall software, and Powerwall software you have to be your computers. Okay, this is the lab 1, so we can ensure that okay, Matlab is basically a very big folder, but Powerwall is okay. So try to manage to install all the things before you are going to the the session. It's always important. Okay, so if we have no questions, then we can end the session. Okay, thank you guys. Thank you for joining.
Thank you, sir.
Thank
Okay,
you,
thank
sir.
you.
Thank you, sir.
Thank you, sir.
Okay, thank you. Assalamualaikum.